Look away from our solar system, beyond the friendly brightness of the sun, beyond the planetary family we've come to know so well, and you gradually find yourself, at least in the imagination, at a dim speck of light in the dark sea of space. That speck is Proxima Centauri, our closest stellar neighbor, a red dwarf star shining dimly just more than 4 light-years away from our world. To put that in perspective, a light-year is close to 6 trillion miles, and Proxima Centauri is over 4 times further away than that. In the more understandable units of miles, it is an almost unbelievable 24 trillion miles away. If our fastest ever spacecraft were to make a trip to it today, it would take tens of thousands of years to get there. For centuries, astronomers and dreamers alike have pondered the possibility of life growing in the vicinity of such far-off suns. The question is an old one. It has been a concern for ancient Greek philosophers, a stimulus for the speculative literature of the 19th century, and the motivation for decades of serious scientific investigation in the 20th century. And yet, in the face of repeated radio searches, surveys of planets, and bursts of optimism, no irrefutable evidence of extraterrestrial life has been found, until now. Nothing could have readied the world for the discovery ushered in by the James Webb Space Telescope, the world's most advanced pair of eyes on the universe. Conceived to look further out into space and back in time than any earlier device, JWST has opened a window into worlds that had until recently been only entries in data tables and ghostly silhouettes in starlight. But its most recent find has not simply pushed the limits of potentiality, it has destroyed them. The telescope eye has been trained on Proxima B, a rocky exoplanet revolving around Proxima Centauri in the star's so-called habitable zone. At a little more than 4 light-years from our planet, it is the nearest potentially life-bearing world outside our solar system. And what JWST has witnessed on its nighttime side has astounded even the most conservative of scientists: city lights. Not the natural glow of lava flows, not the shimmering drapes of aurorae, but lights, artificial, organized, and patterned in ways that cannot be explained by any known geological or meteorological process. This was no sensor trick, no brief glitch. The discovery was a result of diligent observation, months of tuning, and continuous verification. JWST's infrared sensors, specialized to detect the weakest thermal signals, had been charged with probing Proxima B's atmospheric composition. The mission's initial objectives were modest: look for evidence of methane, water vapor, carbon dioxide, and other molecules that could suggest a life-conducive environment. But in examining the planet's dark hemisphere, the one hidden from the intense glare of its parent star, scientists found something surprising: rhythmic bursts of light, subtle but insistent, spilling out in recurring patterns across the surface. The lights did not scatter at random. They bunched into lineal groups, extended into pointy grids, and arced to follow coastlines or geographic borders. They flashed and faded in sync, implying cycles of activity, even something like human night and day cycles, except on a planet where one half is always facing its star and the other is always in perpetual night. Natural phenomena couldn't account for what was observed. Aurorae, even if Proxima B possessed a magnetic field capable of creating them, would jump erratically, not sketch neat geometric patterns. Volcanoes, however active, would blaze randomly and not array themselves in neat rows. The sheer size of illumination, observable from the other side of interstellar expanses, led to one conclusion: the lights were created by intelligence. The ramifications were staggering. City lights don't only suggest the presence of life, they suggest the presence of civilization. In order to generate them, a civilization must produce energy, plan infrastructure, and coordinate on huge scales across large areas. The patterns observed indicated areas of dense settlement connected by sprawling, interconnected systems. The dimensions were gigantic, promising urban complexes that might extend hundreds of kilometers. For light to be seen over more than 4 light-years, they would need to be extremely bright, pervasive, or both, very likely brighter than the cities of Earth at night. The conditions on Proxima B make the accomplishment all the more impressive. Due to the planet's close proximity to its star, it is likely to be tidally locked, with one side seared by constant daylight and the other under constant darkness. The lights were on the night side, in areas where the starlight never reaches the ground. This implies that the residents, if such they are, might have elected to dwell, or adapted to live, in the perpetual dark. Such a decision might be pragmatically expedient. The star is a red dwarf and notorious for violent stellar flares and radiation bursts that might incinerate the sunlit hemisphere. The dark side could provide a shield from this danger, though at the cost of control over heating, farming, and light itself. And control they appear to have mastered. The mere fact that this light exists suggests answers to problems mankind has yet to dream of: gigantic climate control systems, radiation shielding devices, power grids on a global scale, possibly even artificial suns. Perhaps they have a way of transmitting energy we have yet to discover, sharing power wirelessly or through some medium that our tools cannot detect. Their lighting could be many orders of magnitude more efficient than ours, permitting them to bathe their world in light without depleting resources. The finding has also injected fresh life into one of astronomy's longest-standing philosophical conundrums, the Fermi paradox. For decades, people have inquired, if the universe is so big, where is everybody? The silence has been confusing, even chilling. Now, it seems the silence was not real. Someone is out there, someone advanced enough to mold their night into a lit-up tapestry visible throughout interstellar space. The lights themselves dim varyingly with time, as if reacting to cycles we are still unable to decipher. Even some researchers have hypothesized the possibility that the oscillations can be deliberate signals. If they are signals, what might they mean? Could the inhabitants of Proxima B already be aware of us, having observed the glow of Earth's own cities? Our planet's night side, seen from afar, would reveal its own shimmering constellations of human habitation. Perhaps they recognized the parallel, saw in us a kindred spark of civilization, and decided to send a quiet acknowledgement, not in words or radio pulses, but in light. Technically, the detection is a breakthrough for exoplanetary science. So far, attempts to find life outside the Earth have focused on either finding atmospheric biomarkers or tuning in for intentional radio signals. Artificial lighting is a third avenue, one that may be particularly promising for tidally locked worlds such as Proxima B, where systematic lighting of the dark side would look starkly against the cold, black background. This might even alter the boundaries of the Drake equation, which calculates the number of detectable civilizations in the galaxy. The cultural and psychological shock on our planet has been immense. For the first time in the history of humanity, we know, beyond the bounds of reasonable doubt, that we are not alone. The philosophical implications are staggering. Religious traditions may redefine humanity's place in the universe. Political structures will be forced to grapple with the fact of an adjacent, potentially technologically advanced civilization. Even on an individual level, the news provokes something deep-seated, a mixture of awe, dread, and fascination that knows no borders or languages. And perhaps this is only the start. If JWST can find city lights on a planet more than 4 light-years from us, what might future generations of telescopes discover? The Milky Way has more than 100 billion stars, and we now know that planets are widespread. Many of these planets orbit in their stars' habitable zones. It is quite possible that civilizations exist all over the galaxy, just waiting for our tools to become fine enough to see them. With this revelation, exploration is a two-way street. If they can create lights of this size, they might also be able to communicate interstellarly or even travel. The most important questions now are pressing ones. Are they friendly? Are they interested in us? Or are they uninterested, like we once were with the faint spark of a faraway campfire in the woods, interesting, but meaningless? The Proxima B lights arrive with no greeting, no warning, just the sterile, factual radiance of man-made light cast over an alien world. The patterns suggest a sophistication we can only speculate about, clumps that could be city centers, softer webs that could be transit routes, abrupt bright nodes that could be industrial centers or power sources. Some areas fade slowly over time, and others burn consistently. There is a cadence to the alterations, but it is unrevealed, and yet, despite all the conjecture, one fact cannot be avoided: someone is home. They've built. They've ignited their universe. And on the other side of the unfathomable chasm of space, we've viewed it. That alone makes everything different, not only our science, but our narrative as a species. See you again in another video.